Good morning, everyone. I'm just going to start. It's 10 o'clock, so I hope everybody is sitting well, and yeah, we should be able to do this. Can everybody hear me loud and clear, also in the back? Yes? All right. So we're trying a different setup with the lights. This might look a little bit strange, especially if you only look at my face, but the slides are better off this way. So yeah, I hope everybody can see that those two. My name is Matthias Nobak, and this talk is about package design, more specifically the principles underlying package design, where a package is just any kind of reusable piece of code that you would like to share with yourself, your company, your university, or the whole world. You may know me from my blog. It's about PHP and Symfony. Symfony is a web framework, in case you didn't know this. It's a framework that I like particularly, so I decided to dive into it, learn as much as I can about it, and to write articles about the framework itself and how you can best use it. So after I was doing this for a couple of years, I wrote this book. It's called The Year with Symfony. It gives you some more insight in the inner workings and some advanced way of using it. Also, what's interesting for my own personal development is that the last chapter is about moving away from the framework itself and trying to prepare your code for reuse. And well, there are some suggestions for the ways that you can prepare your code for such reuse. And so, as you can see, I'm moving further and further away from the actual framework-specific code, and I'm always trying to look for ways in which more people than just the Symfony community would be happy to use the code that I write. So in a way, you could say that for a long time I have been tightly coupled myself to this particular framework, and now I'm looking around a bit. And I'm also looking from a bit higher perspective at my own work. So this is the way I envision it, and it's just like writing code all day, regrouping that code into useful functions, and then again regrouping those functions in classes. And well, then sometimes you may think that it may be useful to regroup those classes into even bigger units or bigger components, and those are called packages, of course. When I talk about packages, there are many different kinds of them. You can have private packages for your own use or reuse. You can have public packages. You can have open source packages. You can have maybe closed source packages that you just sell in some way or another. There may be strict boundaries, so a package may have a package definition file, but it also may just be a set of files in your project. It may even be just one particular namespace that you never thought of as a package, but still can be considered to be a package. And the following, everything I'm going to tell you about design principles should be applicable to all kinds of packages, these private and public, open source, closed source packages, any of them. So whenever we're looking for design principles for classes, there are a lot of them, and many are very familiar. So you may already know about the solid principles, any other kind of design techniques like encapsulation or polymorphism. Those should be very familiar, I think, by this time. But for package design, there seems not to be anything like that. No such thing as package design principles, only class design principles. Even though packages are becoming more and more important in our everyday work. I think many of you also try to use as many packages as possible that are of high quality, but in a way that you don't have to write all the code yourself. So it is important to know what should be considered to be a good package, and which packages are trustworthy, can be relied on. Well, so during this talk you will learn some things, some principles by which you can judge any existing package on its quality. And the funny thing is that I thought there would be no such thing as package design principles. Nobody would have written about this. I mean, I never heard about it before, but I came on this website, butunclebob.com. It's a website owned by Robert Martin, and I mean, he's the one that coined the solid principles term. But he also has 6 package design principles. I must say it's not all original work by him, but he's just expanded on existing work and recombine those things and put nice names on it. And so this is very useful. I mean, many people will be able to understand these principles, especially if you're somewhat used to object-oriented programming. When I stumbled upon them, I thought, well, they are probably not that famous, so maybe I just dive into this and start to research a bit about it. And then in the end, I thought, these principles are very, very useful, and I think every PHP developer, and in fact every developer in the world, should know about them in case they want to release some code as reusable code. So yeah, I decided to write another book. It's called Principles of Package Design, and this is the particular goal I had in mind, is to tell everybody about the ways you have to be thinking about and be writing your code for packages specifically. So the question is always, how can I optimize the experience for the users of the package as well as for the maintainers? And these seem contradictory most of the time, but they really are not. So if you apply the following package design principles correctly, then your package will be better usable, but it will also be better maintainable. So that helps two kinds of people. Looking at the package design principles, we can separate them into two groups. The first main group is a set of 3 principles, and they are about cohesion. And I think cohesion is something that every one of you will already know about, even though you may not be able to explain the word properly as of now. Cohesion is also about combining things together, belonging together. And if you're looking at the code, you always have to ask yourself, does this piece of code belong right here? And shouldn't be it in some entirely different place. In other words, it allows you to label the cohesiveness or the sense of belonging together of one group of classes, for instance. And so if you look at these images, you can see that, well, I think they should be able to represent packages in a way that the red package, well, clearly misses something that is in fact available in the blue package. So, well, there is a cohesion problem there. It should move from the blue package to the red package. And as you can see, there are several green packages right there. They are so highly cohesive, but they are still not very much together. So it might be just best to move all those things into one package. The yellow one, yeah, it has some cohesion problems as well. I don't even know, well, it tries to do so many things at the same time. So we might just want to create some nicer, smaller packages for that. Just some examples, some visual examples. Then there is something called coupling, also for packages, just as it is for classes. And there you look at how different packages need each other to do their work. So you take a package, you draw a line from one package to another one, and you can judge those lines, those dependency lines. So you can always say, this is not a correct dependency, it is unsafe to depend on that package, or maybe like in this example, there is a circle between the dependencies. So the green one depends on the orange one, and it depends on the green one again. So in a way, you have to remove those dependency directions. So let's first take a look at the first 3 principles. They are about cohesion. What's important to keep in mind is that if you're talking about cohesion for packages, you only have to look at one package at a time. So cohesion is about one package, not about its relation with other packages at all. So the question is, what's inside a package, and does it belong there? Shouldn't it maybe be in another package, or should we combine several packages into one to have better cohesive packages? The first principle is called the release reuse equivalence principle. That's just a very very interesting name for the idea that the granule of reuse is the granule of release. So you can reuse only as much code as you can properly release, and any code that you release is reusable. So this goes both in both directions. The thing to keep in mind is that if you want to reuse some code, you have to properly release that code. It's no use if you release code using, for instance, sending an email to a teammate, and you say, well, this is a piece of code you can reuse. But then that is not a proper release. It's not entirely useful for the other person because, well, any bug fixes that you may have for them, they don't get that automatically. So there are so many things really you have to take care of when you're releasing code, and this principle sort of reminds you of that. Just a quick list of things you have to think of when you're releasing code. And Well, the list is actually much longer, and I can talk about this for hours, I think. There are so many things you have to do whenever you're releasing code. Well, one thing you have to take care of is proper version control of the code, so no sending emails to each other. It's just, it has to be in a version control repository. You have to provide the proper meta files, like a license file, a README file, at least somehow explaining what the package is about, is supposed to do. You have to make sure that every file in the package is already available using some kind of auto-loading mechanism. There should be almost no things that a user has to do before they can use your package. You have to, of course, have a nice package definition. You have to set up the requirements for your package. Maybe your package needs other packages to work. You need to think about version constraints, so you don't want to limit them too much, but you also don't want to make them too free. So those kinds of things. And in particular, if you ever release code, you have to be very careful about backwards compatibility. This is something you all know of, I think. Whenever you upgrade something and then something goes wrong, I mean, we can just talk about PHP itself. These things happen all the time. And well, as soon as you start releasing your own code, this is your task to make sure that nobody experiences such problems with your own code. And well, you can also say that, well, but then you have to put a warning in your README file that you're not going to maintain this in a way that maybe some people would want. But I think most of you, if you ever release code to be reused by other people, then you definitely want to provide backwards compatibility. And this alone can be a lot of work. And so the conclusion is really, if you don't have time for that, if you cannot properly guarantee that you are going to turn your package in a real product, a nicely behaving product, then, well, maybe, and this doesn't sound very friendly, you maybe should not release that package. Or just add a little note on top of the README file saying, this is very nice, but it's experimental, and I'm not going to take a lot of time to maintain it. So yeah, and at the same time, this doesn't mean that I want to discourage you to release packages. I mean, it's a great experience, and it's really nice to see people use your code in other projects. But you have to take proper care of it. And there is, in this way, this is actually about cohesion, since it's very hard to maintain very large packages. So you may decide to go for a small package with just one very particular feature. Well, just a suggestion. Then the second cohesion principle is the common reuse principle. It says that classes that are used together are packaged together. And so, well, this sounds very good. I mean, if you want to use several classes and have to install several packages, that doesn't sound good. It's better if you have one package containing those classes that you want to reuse together. But at the same time, if you take a package and you look at one class and you look at another one, and you don't use them together necessarily in your project, there's something wrong. So the idea here is that if you use one package in your project, you should be able to use every class of it, and you should also use every class of it. As soon as there are classes that make sense to be used separately from each other, then it may be time to split up the package. So this is meant to prevent you from putting everything that is reusable in one package. One way in which you can spot packages that violate this principle is by looking at the features they contain. And there is a package smell, which is called feature strata. I invented the word myself, so I can explain you what it means. Strata, just parallel layers of code in this case. And looking at the colors of the classes in that package, you can see that the orange ones together implement one particular feature. And there is a set of green classes, they implement another feature, and finally a set of red classes, and they implement quite another feature. Each of those features can be used separately. They have no interdependencies. So actually, it really doesn't make sense to have them all in one package. You can see this in practice when someone needs to load this entire package in their project, but use only 2 or 3 classes from it, even though the package itself contains maybe 20 classes. So that's a package design smell. One example is from my actually favorite project, Symfony project, the Symfony security component. It contains features for ACL, access control. So there are core features which are needed by all of the other features. There is CSRF for cross-request forgery protection, HTTP features to support logging using forms, for instance. and then some other things. But basically, these components, ACL, CSRF, and HTTP, require a core, but they can be used entirely separately. So it totally makes sense to have separate packages for them. And so the Symfony maintainers did this. They already split this package. And it totally makes sense because it's not really about the amount of bytes that you have to have on your disk or the amount of code that you include in your project, even though that can be a danger too. It's more about keeping track of changes. So if you have a user for this security component, and well, of course, security is very important. So they have to keep track of all the changes that occur within this package. And well, if there were no separate packages for all of these features, then people would have to upgrade the main package all the time because of important feature fixes. While most of those changes shouldn't be relevant to you at all, since you only use one small part of it. Yeah, so it's important to really split those packages into multiple ones. Well, just like the maintenance team already did for the Symfony security component. Then another sign of packages violating this principle is that well, when one class in the package needs another dependency, then another class. So there can be other packages that are only needed by a very small part of this one blue package. A great example would be, I think many libraries are great examples of this, but for instance, a file system abstraction package that I know and have worked with, it's called GoFret. It contains all kinds of adapters to work with particular file system storages and to abstract the differences between them away, so that you can just say, I want to store this file on an unknown file system, and then the adapters contain the detailed implementations for that particular file system. But the problem is, of course, that with so many adapters, most users will only pick one and use that in their system. For instance, they will store their files on Dropbox. I'm not sure if that's a good idea, but if you do, then you're probably not going to store files in another place at the same time. So it's very likely that you will only use one of those 20, 30 classes of this package. Well, why again is this bad? Most of the upgrade changes made to this package are about adapters that you don't use. So you have to keep upgrading the project even though it doesn't make sense to you. And upgrading a project is always dangerous. There may always be changes that you didn't know about which will break your own project. So again, create separate packages for this. And make sure that that you don't lie about dependencies. Or, I mean, it sounds a bit harsh for me to say lie, but this is a way that you can use the package definition file for PHP. It's a composer file, and instead of saying I require these packages for those particular adapters, this package says I suggest you install several other packages in case you want to use the Dropbox adapters, for instance. And this is totally not true. I mean, the code in the package cannot be executed without these dependencies. So these are not really suggested dependencies or optional ones. They are actual required dependencies. And if you think about this, there is maybe no such thing as an optional dependency. It's, if you need it, then you really need it. If you don't need it, then you don't. So there's nothing in between. So in a way, this hides the true dependency graph from sight. The funny thing is that I talked to the author of the library, and he said, I agree with you in 100%. By the way, it's a beautiful name, Leszek Brabuski. That's just very nice. But he said, yeah, we should have each adapter in a separate package, and each package should have its own maintainer. That would be great as well, since several people, or one person cannot know everything about all these different file systems. So it's just really great to have separate maintainers for those adapters, and that will make sure that it has the best of the best maintainers that are out there. Still, as he says, currently this can be difficult to achieve, and I agree with that too. So you have to manage a lot of people working together. So yeah, there maybe has to be some kind of a golden middle there. Next, the common closure principle. As you know from your code, there may be lots of external influences like Pac-Man or scissors, if you recognize that as scissors. But well, your code is influenced by many changes. So sometimes, well, for instance, you may use a PHP version and then you upgrade it, and well, that change in itself already forces you to change your own code. which is an external influence. Also, if your boss comes in and says, we have to change this, then yes, your code is going to change because this person asks you to do this particular thing. And so whenever you maintain multiple packages, you want to make sure that the number of packages that you have to touch because of a required change is the smallest possible. Otherwise, you have to open all those packages, make all those changes, push new versions of it, and it will just be a lot of work. So just you have to make sure that the change is limited to the smallest number of packages. And well, you can think for reasons for change about, well, for instance, the features change, or some kind of rule about the business changes. Maybe, well, if you one day read some blog post by myself and then see, oh, this shouldn't be done in this way, I'm going to change this right now, then that will cause lots of changes all over the code base as well. And then you want to limit the number of changes to the smallest number possible. Also, what you see many times is that one package contains code for all kinds of application layers, like code for the web, templates, like command line code, model code, infrastructure, all kinds of things thrown together into one package. And yeah, this gives problems as well. So it's always good to separate those as well, and to allow people to not use your templates, but instead only use your model, for instance. That can be very useful. The next group of packages is about coupling. And as I already said, coupling is about looking at the relations between several packages. So you take this orange package in the middle, and you try to draw all the dependencies surrounding it, dependencies inwards and dependencies outwards. Keep in mind, though, that you cannot analyze or inspect the entire package ecosystem. That would be just too much work. And in fact, it's all about the packages actually installed in your project. So you have to always take care that those dependency directions are proper. And what are proper dependency injections? Well, we will learn that today. So first of all, the acyclic dependencies principle tells us that we should have no cycles in our dependency graph. Even though maybe package managers would be able to resolve those circular dependencies. I mean, there can be problems with that, but you may be able to fix that by just helping it in a way to point out those circles yourself. But yeah, it will usually bring you a lot of trouble. And most particularly when you're trying to upgrade packages and, well, or at least release them, release new versions of them. Since if you want to release version 1, or maybe let's say version 2 of your package, and it needs another package, version 3 maybe, but that package needs to have version 4 of another package, but that version 4 needs version 2 of your package, then you will end up waiting for each other, releasing the actual next major version. And so there's not a real solution for that. You will never know if everything is going to work once you have released all those versions, since they cannot be installed properly at the moment. So you will have to do some kind of a big bang release where every package is upgraded to its new major version, and then you just have to hope that it will work out. So in general, I think that, and I'm sure many of you will agree with me, that cyclic dependencies are dangerous at variable level, at class level, but they are also dangerous at package level. And so, well, this is just a nice quote. Somebody asking about the package manager for PHP wouldn't be able to solve circular dependencies. Well, it is able, but yeah, he says, well, in the end, I chose to refactor my code to remove this particular code smell. So, and it's very easy to remove these cycles as well. So mostly it's about regrouping packages to depend on itself, which is entirely safe. Maybe there's another problem where you have to extract a new class and put it in its own package to invert the dependency directions. That should not be a problem at all. Then the last two of the principles are about stability, and it's really fascinating for me to. I mean, I had been using stability as a word, well, when I was talking about software, but I never thought about this, what it would mean actually. And well, you could say that something is stable if it's resistant to change. Well, this never came to mind, but it's really nice to think about it like that. So you know that a person is stable if they aren't easily affected by things that are happening in their surroundings. So any external forces are not able to influence them. And the same goes for a stable building. It's not likely that such a building is going to collapse, since it's just stable. You know, there are no reasons for it to change. It will stand as it is. So the funny thing is that a person and a building are somewhat different from software, because a package is stable when it's unlikely that it's changed by external forces. And the thing is that stability is now not an internal quality of the package, but it's an external quality. So external or other packages are able to influence the stability of a particular package. And that's interesting to note, and it's also interesting to look at the different kinds of relations that a package can have with its surrounding packages. So first of all, this is a package, and no other package depends on it. So it can do anything it wants. It can change at any time it likes. So this should be considered an irresponsible package. It has no responsibility to stay the same over a longer period of time. Well, these kinds of packages are very nice, since when you are the maintainer, you can change anything you like, and nobody will even notice. So that's just great. At the same time, we can look at this kind of packages and say that it is a dependent package. So the orange one has multiple dependencies. It depends on many things, so let's call that dependent. The problem with dependencies is that they, as I already mentioned, are able to change your code as well. So when one of your dependencies changes, it has a new upgrade, some change, some backwards incompatible change probably, then you are going to change because of that. And there's no way you can prevent it. If you want to use the new version, you have to change your code as well. So being dependent is a bit dangerous. It allows you, or it makes you, well, a bit unstable, since you're likely to change because of external changes. And together, these two combined, so the orange package is completely irresponsible. It's also very dependent. This makes a very unstable package. And so the funny thing is that the orange package, well, it can't really help itself. You know, just the way that it is surrounded by packages and the way that the dependency directions go make it an unstable package. Then looking at the other way around, this is an orange package, another one, and many packages are depending on it. So we could call this one a responsible package. It shouldn't change all the time, because then lots of other packages should have to change too. And this is the problem, of course, with well, the PHP language, but also framework packages. It's hard for them to make changes, because everybody will be angry about the changes they have to make as well. So in that way, these packages tend to be very stable and not make any big changes at all, because they feel responsible, and they are. Then if we look at the arrows down towards other packages, we can see that this package is completely independent. There are no other packages that it needs to do its work. And this also means that it's not likely to change because of other packages. So when it would have many dependencies, it would be likely that it one day needed to change its own code. But now there are no dependencies, so no reasons for change, except internally motivated ones. These two combined, we could say that the orange package here is very responsible. It's also very independent. And these two qualities of a package make it very stable. So it's not very likely that this package is going to change at all. It's just going to remain the same, except, well, for the usual reasons. If you, at least, sorry, that was a shortcut. I was meaning to say for reasons internally motivated. So there are no external changes that might make this unstable. The stable dependencies principle says that when you have when you have labeled a package stable or unstable, or somewhat unstable or somewhat stable, you should draw a diagram of those packages and check if the direction of those arrows leads only to more stable packages. So depend in the direction of stability. As you can see at the top, there is an irresponsible package. There are no packages depending on it. Still, it is dependent on the green one. and the green is also dependent on two other packages, and there's only one package depending on it, so it's somewhere in between stable and unstable. At the bottom, there are packages that are only dependent upon, but never depend on anything else. So those should be considered very stable. So this arrangement of packages fully conforms to the stable dependencies principle. But then this diagram shows a problem where there are several irresponsible packages. Those are also dependent, meaning they are unstable. And then they depend on some package that is, well, quite stable, somewhere in between it. But then the green package depends on a package that has many other dependencies, which makes it unstable. So the direction of stability is not downwards, but it goes up towards less unstable packages. And yeah, this violates the principle. I'm saying up and down, which is not really relevant. You could also throw the entire diagram upside down. But the convention here is to draw the more stable packages at the bottom and the more unstable packages at the top. So that's why I'm saying up and down. Also, the final principle is about abstraction, and we can nicely combine the two. So we have the stable dependencies principle. If you're drawing a diagram for packages from unstable to stable, then the dependency arrows should only point downwards. The same goes for abstraction. So as we will see in a moment. A question for you. What is more likely to change? Is that something that is concrete or something that's abstract? Concrete. Yeah, the first answer is the right one. Why is that? It just is, right? No. Well, at least something is concrete if it contains implementation details. And it's the details that always change. Someone comes in and says, we need to get another number of things. We need to use another library or something. Yeah, so that is very concrete. Those are details. Those have to be changed. The abstract things usually stay the same. And this is also the entire intention of using abstract things in your code, to move away all the practical details from sight and to depend on something that is likely to stay the same for a longer time. So yes, what is more likely to change, a class or an interface? When we consider a class to be concrete, then the interface as abstract, well, then the interface is less likely to change, and the class is likely to change. So the next question would be, where would we put interfaces? In what kind of packages? Stable or unstable? Stable. All right. So yes, and that is entirely true. Since those interfaces are not going to change all the time, we want them to be in packages that also are not going to change all the time. Since if an interface would be in a package that changes all the time, then that would render the stability quite useless. So this is what the stable abstractions principle tells us. Abstractness should increase with stability. If we draw the same diagram again and find some kind of a numeric indicator for the abstractness of a package, that is to say the number of interfaces versus the number of classes, that would give a nice indication of it being a very abstract or a very concrete package. And then if we draw those packages again, we have to make sure that we only depend on things that are more abstract. And yeah, so, sorry. Oh, I'm missing a slide here. There is a slide missing, and the slide should show you the same kind of package diagram with some indication of it being abstract or concrete. Well, I think you can picture that in your mind, or you have to, because there is no concrete one. All right, so we have seen the 6 principles right now. And well, just as a way of quickly memorizing them, the first one was reuse, release, equivalence principle. And it says that you can only reuse code that you actually can release as a product. It makes no sense to reuse code that is not released in any proper way, since that will give you a lot of trouble, especially your users. The next one is the common reuse principle, and it said that all code in a package is reused at the same time. If you find a package with a class that can be used separately in a meaningful way, then it should be split. The common closure principle says that a code in a package only changes for a few reasons, or, well, in the best case, for just one reason. So you have to make sure that whenever you start modifying your code, you have to touch the smallest number possible of existing packages. Acyclic dependencies tells us that there should be no cycles in the dependency graph. All right. Stable dependencies only depend on more stable packages. So don't start depending on packages that have many dependencies themselves. That will make your own package unstable. And stable abstractions at the same time would say that the more stable packages should also be the more abstract ones, and the more unstable packages should be the more concrete ones. So the concrete packages will contain lots of classes, implementation details, and then those will depend on abstract packages containing more interfaces. All right. Well, just one quick word of advice. You cannot use all of them at the same time. You cannot make your code follow all these principles. But if you keep them in mind, well, I think the experience in general will be a nicer one for you as a maintainer as well for the user, since you will have less problems with dependencies that have troubles. It will be easier to just pick one little package and use it just like you want it to be. And it will make, in general, your entire project more stable if you judge existing packages by the way they follow these design principles. Little advertising. You can buy this book by me about the same subject on leanpub.com. I also have several paper copies with me today, so if you're interested in this subject, then come to me and ask for them. And finally, I would really like to have some feedback on this talk. It's on Joined In. I'm not sure if you can see this. join.in/130457. You can find me on Twitter if you want to discuss something in a more digital way. And well, maybe there is a couple of minutes of question time left. So, anyone? All right, just behind the. So let me just walk over there. That's better.
This is about the topic of the adapters that we talked about. You were saying that it would be good if you have a lot of adapters. They would all go into their own package, right?
Mm-hmm.
I can understand that for a library, but how does that work with an application? Let's say I write an application that lists files,
Mm-hmm.
And I don't care about the adapter.
Mm-hmm.
What kind of dependencies does that application have towards, let's say, I want to make an application that lists files,
Mm-hmm.
Dropbox or S3 or whatever.
Yeah.
What kind of dependencies do I have on my console application?
Right. So yeah. Right. Yeah. I was thinking about how to do that. Yeah. So the question is about the adapter packages that I mentioned for the file system abstraction. But in your application, you need only the abstract stuff or the abstract aspects of that. Yeah. So in your package, you would depend on an abstract package. So it should be the core package of the file system library. And then the project should also have one or two concrete adapters dependencies. So you can just add the dependencies that you like to use.
That means that the application needs to know about those implementations. But let's say I don't want to know about the implementation.
Mm-hmm.
Somebody else can make another adapter, and I want to use
Right.
it.
Right.
Is there a way to do that?
So again, another question. The project would have to know about the concrete dependencies, the concrete ways in which it talks to specific file systems. Yeah, I think this is no problem at all. The application is the most concrete thing about your code, and it contains all the configuration and all the details about how to connect with, for instance, Dropbox if you want to use that. So yeah, on the application level, I would say it's no problem. If you're creating a reusable application, if that's your maybe an e-commerce platform or something, then you would have to provide no concrete implementations again, but you would just have to ask for your users to do this. And well, the PHP package manager has something, it's called Composer. It has an option to ask for packages that provide, this is the provide key. You can ask for packages to provide an implementation for a file system, for instance. So look this up, provide in the documentation, and yeah, and package maintainers can label their packages and say that it provides a concrete implementation for a file system adapter. Yeah, so that's very useful. All right, thanks. Any other questions? So the question is, if I start creating a new package, then it will be very hard to follow all these advices, all these principles. Which one is the most important, or, well, how would you deal with that? I think common reuse is the common reuse principle. I think this is the most important one because it tells you to not put all kinds of different things in one package. And yeah, so in the end, the most practical advice I would give is to start very small. Create one very small package with just a few classes, which offers one solution for something. And then, of course, make it extensible so other people can create new adapters for it. But yeah, you will have some experience with maintaining the package. And I think it should work out. For me, it always has worked out to pick just one small feature, not trying to create one big application or offer solutions for everybody. That's too hard. Right, thanks. Okay, one?
Yeah, regarding breaking changes, how should you handle internal changes in the code base? Because it's not possible to have external APIs for a package. Like in Java, you can have the visibility of classes for recipient to a package. Is there a way to handle this in PHP, or do you have any suggestions how to do that?
Yeah, the question is, how do you handle package visibility? So when you're working, or when you're trying to provide backwards compatibility, it's a real problem that everything in PHP is out in the open. So as soon as your package contains one class, it might be possible that someone is using it, and even though you think it's private to the package, yeah, how do you go about changing that code? True, and this is why it would be really great to have package visibility sort of indicators or scopes for PHP itself. When this is not going to happen for now, I would say you have to maybe document this somewhere. You should also use, or you can use, annotations for classes, saying that this is one that belongs to the official API. So you say at API. This is a bit of a convention right now. To mark classes and methods to be well supported by you in your backwards compatibility promise in a way. So there are no real good ways to do this, but there are conventional ways to accomplish the same thing. All right. So I think one last question, or? Okay. Yeah. Right.
Did you use a metric to calculate how stable packages?
Yeah, there are these metrics. Robert Martin mentions them as well. They are about the number of ingoing and outgoing connections, and well, just calculating the ratio for that. It's actually that simple. So you just count the number of class dependencies going inwards, and those going out. Divide those, and then that should be the instability.
And does this also keep in mind the other requirements of the other dependencies? Change down all the way? Or?
No, it hops from package to package. So if you, it doesn't take actually the instability of other packages into consideration. It's just one number which just applies to one package, and then you can draw the entire diagram, and then it will show whether or not you have applied the principles. Yeah, there is currently there's project pdepend, which allows you to analyze classes in more or less the same way with fan outs and fan ins. But it doesn't work for actual composer packages. So it only takes either namespaces or, I'm not sure, the add package annotation into consideration. It would be really great to have a change in that package, pdepend, so that you can just analyze your entire project for these kinds of, well, I mean, if you're doing it by hand, it would be too much work. Yeah. All right. So I think that's it. Thank you, and well, have a nice day. Thank you too.